Okay. We'll wait for another 5 seconds, and then we can start. Okay. So, hi everybody. I'm Roy. I'm head of automation at Wix, and today with me is Elad. He's a team leader in our group. Today we're going to talk about the test state pattern and how it can help everyone achieve much more stable automation. So our story begins. It used to work like a second ago. Okay. Okay. Wow. Whoa. Okay. Okay. It's a spoiler. I'm trying to go back. Okay. So our story begins in ancient Egypt, of course, as you probably know, and the most famous pyramid of tests, right? A lot of unit tests, less integration, and much less E2E. But there's some kind of problem in there, which brings us to the problem. And the problem is that end-to-end tests have much more breaking points than any other tests. And you know, the reason is obvious. You have a lot of components, and you test the integrations between those components. And sometimes it's even testing different systems, like the whole scenario. And you know, it's obvious that it's a lot more difficult to write those. And writing new end-to-end tests is even much more difficult to do. And the reason is that, just a second. Yeah, I think, no, it used to work before. Yeah, yeah. Okay, amazing. Sure. So, okay, I just need to be closer to here, probably. Okay, so end-to-end tests have a lot of breaking points, and writing new ones is even much more difficult. And the reason is that, you know, we write a new test, and we check it on our local machine. And our local machine is, no, it's not remote, it's local. We have one browser, and we have a strong laptop, and everything is OK. And then when we try to test it remotely in some kind of CI or whatever, and it's running with a lot of other tests, it suddenly starts to fail, and we get some flakiness. And usually it's because of timing errors or just remote connection, which sometimes break. And of course, we also have bad luck sometimes. And this is, of course, really not good, and this is what we try to avoid. This is what we call false positive, of course, and it reduces the amount of how we trust the tests. And if you write a test and it's not stable, then we don't trust it anymore, and we say, OK, this is the test which always breaks. And it's, of course, really not good. It causes a lot of noise in the analysis, especially when we have thousands of tests. And of course, the shame, nobody likes the shame. Shame. So we have a lot of tests. Some of them are unstable, or in a worst case, a lot of them are unstable, and those are end-to-end, and it's causing a lot of noise. And it's running, no, it's not good, as we said, but we need to find some kind of solution. So our first solution, when we've encountered this problem in Wix, was to create some special annotation, which we used to call beta test. And then we split all those tests to different groups. New tests were given this annotation called beta test. And the stable tests, okay, the old ones, were just annotated with the regular JUnit test annotation. But this is, it's kind of problematic because we have two different groups of tests, and then we decided to only run the stable ones and to do something else with the beta tests. So we have less coverage, of course. If we have a new test, it's still in beta. It's not really running if we want to test the product, and only the stable ones run. So let's continue with this idea, and then we will see what to do. OK, so this is how we use it. If we define a new test, this is just an example with a JUnit. So instead of just JUnit's regular annotation of test, we use our own, the beta test, and we provide an owner, the name of the owner. In this case, it's CP, the one who wrote the test. And this is how it's annotated. But now we need to do something with those tests, and we decided to run them in a different group, to run overnight a lot of times. And in every run, the test reports its result to some dedicated server. So we have all of the data in some kind of server, all the pass tests and failing tests, and then we can do something with it. So it's running overnight, multiple times, of course, because we usually sleep at night. And the system is working. All of the new tests of the same day is being run overnight to check, to validate if it's OK or not. Now, there are some issues that we need to understand on how to do it, and there are a lot of options. This is just one of those. So we have two groups. We have two annotations, and we need to decide in every run what to do. So one simple solution is just to understand whenever a test starts to run, we check if it's annotated with beta test, and we will cross-reference it with some kind of environment variable in the run. It's just one option. We can either do this or run all the beta tests together in some kind of configuration. It's just one idea, and it's quite simple. A test starts running and then checks. If it's beta and we're now trying to run beta, it's OK. If not, we just ignore it in runtime. So this is quite simple. And we have now some kind of mechanism to understand and how to run those two different groups. But now we don't really want the beta tests to stay beta forever, of course. We want them to become stable, because until they are stable, they are not really running in production and not really giving us coverage. So we need some kind of way to approve those tests. And what we decided to do is to find, of course, the stable one. But how do we do that? We need to somehow search for them. But it's quite easy, of course. This is not easy. To find them, it's very easy. We already have a database with all the results. And we just decided on some kind of threshold for a stable test. So we decided that a test which passes some x times in a row and fails only few times, the few times can be 0, 1, 2, doesn't matter, you can decide. This is a stable test. If a test passes enough times, it is stable. But if you remember, we have a specific annotation. And according to the annotation, wow, this is crazy. The annotation determines which tests are beta and which are not. So right now we have a beta test, let's say, and it's stable. We understood that it's stable because we have all the results. And we need to somehow change this annotation. But the annotation, it's inside the code. So we need somehow to tell the owner, if you remember, we have this field in the annotation. We need to tell him to update the code, just, change the annotation, commit, push. But this is a bit problematic. Everybody knows Yuri. You know Yuri? And he is a very good programmer. He writes hundreds of tests every day. And yesterday he wrote 100 tests, and those tests were good. And all of those passed during the night. So Yuri gets 100 tasks in Jira or whatever, what kind of issue management system you use, which tells him to go and for each test change your annotation because it's stable. And this is overhead, and of course we can do better. Yes, we can. And if we think about it, we don't really need the annotation. So let's remove this annotation and just use the regular JUnits test. And we remember that we already have a server. We already have a server which saves all the results. So maybe the server can save the tests also. Let's think about it and define the pattern. So every test, wow, of course, starts in a beta state. We just take the beta idea from before, starts in a beta state, and remains there for some time. I'll just put it here so we don't continue. Yes. OK, for some time, it's running again overnight, and hopefully, it goes to stable after it passes enough times. And we can continue right now to see how things are really running. If you remember before, we did some kind of test, to check some. We had an if clause, and we just need to modify it a little bit, because how we differentiate the tests was according to the annotation. But right now, we don't really have a different annotation, but we do have a server, and we have a state for each test. So whenever a test starts running, we just ask the server, OK, give us the test state, and we will decide if the test needs to run. Again, it's quite simple and can be achieved in different ways, but this is the simplest one. And this is the usual way. We have a beta test, and we hope it's good enough, and it goes to stable. But not always this is the case, and sometimes we have a beta test which is not good, and it fails all over and over for, I don't know, a week, always failing. In this case, we want to do something else, and we call it failed beta, which is, of course, the hall of shame, where all the bad tests are going. They will not continue to run. They will run on the side, and every owner, a person who wrote such test will get a notification. Your test is failing. Please fix it. It's quite important. Don't just push and run, but make sure your test is good, and then continue and make it OK. And of course, it has to be manually fixed. The owner of the test knows his test is not good, fixes it, and then it can go back to beta, because the owner can say, yeah, I fixed it, but we don't really believe him. And our mechanism is already working, and we just move it back to beta, and if his test is actually OK, it will move to stable. But let's say we have a beta test. It was OK for some time, enough time to trick our algorithm, and it moved to stable. And someday, something happened. We don't know. It can be for multiple reasons, but it started acting weird, let's say. And if a test starts to act weird, we just call it flaky. And weird, it's not just fail for a lot of time, because this is actually probably a bug which we need to fix. Unstable or act weird is pass, fail, or what we define as flaky. And this is another state that the test can go through in his lifetime. And again, those tests which go to flaky will continue to run on the side. And if they are OK and stable again, they will go to stable. Our system always monitors everything and will change the tests, every test, to to his appropriate state. So this is like the main pattern or the core of the pattern. And since we are having a lot of fun, we can start expanding it a bit. Yes, of course. Yes. We have a stable test. And maybe there's something I don't know, maybe we don't always want to run all the tests. Maybe a test is too stable, like it's testing a very safe area of the system. And if we have 5,000 or 10,000 tests, sometimes we don't want to run everything. Again, it's just a suggestion. We can do this. We can understand according to the results. If a test is too stable, we can add another state which is super stable. I don't know. We can call it how we want. We can invent a lot of other states. But this is just a suggestion, of course. And then if we have this state, we can somehow, in a specific run, tell our system, don't run the super stable tests. We just want the stable ones because we are OK. We are quite safe. And usually we will run everything. But in some cases, we will exclude those super stable. And again, we can extend it however we want. And we can see the full pattern or the semi-full pattern in the next slide, which is very colorful. And this is a good time to take a picture, of course. So we said we have a beta, which usually goes to stable. It might become unstable, flaky, go back to stable. We have the super stable. And of course, the failed beta, the hall of shame, where all the bad tests are going and hopefully getting fixed and then going back to beta. What else I can say? I see more flashes. OK, this is OK. Of course, the presentation will be available later. So all of those states are mapped to different configuration. We have the beta configuration, which runs only the beta tests. And we have the flaky configuration, which runs only the flaky tests. And the release configuration there on the side is the real production configuration. It runs only the stable tests, or again, the super stable tests. And this is the one who is being analyzed. The flaky and beta are automatically analyzed, and everything is being monitored in our server. All the results are going to the same place. And we always have the background process, the algorithm, which checks all the states. And it can run every few hours, every night, whatever we decide. And it changes the states according to the run results, according to the algorithm we've presented earlier. And of course, failed beta is on the side, which requires manual fixes. And yes, this is possible. If you have a lot of tests, this pattern will help you achieve a much more stable automation. And now we can talk a bit about the architecture. And it's a lovely drawing of a cloud. And we have a backend server, of course. It's split to different modules. Of course, the database, as we said. We have a very nice web view, which hopefully we'll be able to see very soon. And all the tests are running in our different configurations using JUnit and some kind of wrapper system, wrapper module we've developed. And as most of you are probably familiar, we just connect to the test watcher and understand when a test is starting, when it's finished, if it's failed, if it's passed. And then we just use our Java client to connect with the server and report everything. So this is quite easy. And we can talk a bit about how the objects in the system are modeled. So we have a test the entity of a test, which describes the test in some kind of unique way, of course. We need to differentiate between different tests in a good way without weird duplications. So the test name is actually the class name, the method name, the package, and also the module of the test. So in some kind of a weird way, if two different people wrote tests in different projects, we make sure they don't collide with each other. And every test has, of course, its state, which can be stable, beta, failed beta, flaky, or superstable. Creation, update date, and the different annotations. And the most important part is that we have test entity, and we also have a run result entity, which, of course, every test has a lot of run results, multiple, thousands, or even more. And the run results is just tells us if the test passed, failed, which kind of failure was it, and again, the update date, creation, and of course, a lot of metadata information about the result itself, which browser, which framework, which whenever, whatever, and everything we need to do in order to make our algorithm more accurate. So this is in very high level, and right now I think it's a good time to try a live demo, which can be very sad if it doesn't succeed, but I think we're okay, and let's try to do it. Let's try. So this is our server. It looks okay. In production, it looks better, of course, but we have our automation manager, and it's using the test state pattern in our implementation. We have a table of tests. Right now, it's in the bottom, and there are no tests in the system. And we'll show you how tests are added and changing states in the live demo. We have the state bar in here, and we can filter according to different states. And we can search tests, and OK, let's just start writing tests and see how they affect the system. So we use IntelliJ. Hope it's OK. We already created a class called live demo. And let's start with writing a passing test, a test which always passes. And if you have any ideas on such test, assert true is true. OK, what else? Assert false is also good. Assert 1 is 1. Empty method is also good. Let's go with the assert true is true. And we will run this test 35 times, just like this, with a click of a button. We already prepared some background code which does this. This is amazing. And again, every test reports to our server. So hopefully, when we go to the server and refresh, we will see this test. OK, it's in the bottom, of course, so it will be easy to see. And this is the test. It's called pass, right? I guess. Class, package, artifact, everything we take from the code. We have 35 results. This is good. It's working. Wow. We can see every result in its own row, and everything is passed. This is good. Not surprising at all, I guess. Right there on the side, I'll go there. We can see, it was so far, failed and passed counter. And 0 times failed and 35 passed. Exciting. I think we can go back to the code, and let's create a different test. This time, let's make it fail, always fail. And how will we make it always fail? Assert true, false. Assert false, true. Assert 1, 2. Or throw exception. Assert true, false. OK. Should be OK. We will run this test again 35 times, and it's a different test. So hopefully we will see it in a different row. Okay, this is amazing. By the way, we can open source this code of running 35 times if anyone is interested. Okay, we can go back to the server. Yes, okay. So we have two tests. One is called pass, one is called fail. And we can see that the failing test is always failing. This is very nice. And one thing I forgot to mention is that we see, go down, yes, the beta, both of them are in state beta. This is good because the first time a test is being ran in our server, it automatically gets a state beta. It is a new test and didn't prove itself yet. Okay, let's try to make things interesting. Let's create a flaky test, but in the first run, let's make it stable. So again, we will write a passing test, always passing, and then we will see how we can make it go flaky, go crazy. So we will name it flaky. Right now, it's just passing, but for the demonstration, we will need it. Of course, it's okay. Looking okay. It's stuck in debug. We don't need to debug, but it's a secret code. It's okay. But it's okay, right? It ran 35 times. Let's see it in the table. Okay, so the flaky is here. It's also beta. And right now it's 35. Oh, it's 36. Okay. Yeah, it's okay. It won't affect the algorithm. So on the first, let's switch the states. We will run the algorithm now. It will analyze all the tests, and the states will be changed. We hope. So we use it by sending some HTTP request, of course. This is a lovely tool. We hope it worked. Let's open the manager. Okay, so what happened? No tests. Maybe something went wrong, or maybe it's because we just filtered the beta. Okay, so we have one test in failed beta. This is good. Yes, the excitement. It's okay. The failing test is now in failed beta. It should be analyzed, and this is working. Let's try to find the stable ones. We will have two stable tests, right? Of course. We will have two stable tests, the passing test and the flaky, the future flaky, yes? So let's see. Okay, we have two tests which are stable right now, flaky and pass. This is not surprising, right? Everything is okay. Okay, now let's go back to the code and let's make the flaky test flaky. Okay, counters, counter plus plus, modulo, we can use the force of modulo. Every second run, it will change pass, fail, pass, fail. And we just need to make a static field, right? Of course, it's JUnit, yes. Now we will run the flaky test, again, 35 or 36, I don't know. 35 times it's enough. And now this is cool. We have pass, fail, pass, fail. This is like the exact definition of flaky. And now let's see what happens if we change the state, right? Or let's see the result first. We can see the results of the flaky. We will see that those results were updated with some failures. So blah, blah, blah. Let's see. Let's send a request. We will see that the test changed its state, and then we will be very happy. We hope. Okay, so one test in failed beta. This is okay. Let's search for the stable test right now. we should have one. We should have the passing test. We have one, and this is the right one. This is the one which is always passing from earlier. And we don't see the flaky. Where is it? We have filters, so if we click it, we will see the flaky test, and this is it. This is amazing, very exciting, right? The system works, and this is actually quite amazing that the demo worked. Good job. And in order to, to sum it up, having thousands of tests like we do at Wix is very difficult to maintain. And the reason we've decided to use this strategy and to develop this kind of project is that we didn't have a choice. Tests were failing all the time, and new tests are added every day, hundreds of them. And this is something that everyone can take. As long as you use this pattern, you will have a much more stable automation, and that's for sure. Okay, so this is a very good idea, a very good thing to use. And right now, I think we have a lot of time for questions. Exactly 10 minutes. Amazing. So we will take questions now, and Elad will also help me because I'm feeling kind of ill. Okay, first question there. Right? Need the... Oh, we have... Oh, yeah, it's... okay. So Elad will shout. It's okay. It's okay. No, I will answer. It's okay.
Okay. So this tool is you developed your own tool, yeah? Because we use, for example, for this kind of collecting the run and fail, the pass and fail results, we use a test rail, the tool, the service. And why don't you use the test rail, for example? Why did you develop your own tool to collect the test results?
Okay, so I can try to answer, and if I forget anything, that you can also add. In Wix, we try to... Actually, in Wix, the platform is do-it-yourself, so I think it applies here as well, maybe. And also, personally, I'm not familiar with this tool, but in this case, it helped us a lot because we could have tweaked it a bit, and we control the flakiness algorithm and the Superstable or whatever we want. And this is probably why it's a good, I think. So this is okay. It's our patent, let's say. Okay, maybe we can add it. Okay. Of course.
Hi. So I got a question. How do you make a decision on the release candidate? Only based on the release configuration, or you analyze flaky ones and failed beta too?
Okay, I'm not sure I understood.
So you have some failed tests, not on the release configuration, but on the flaky configuration and on the beta configuration. They're failed, and you still make a decision to release this content on production, or what?
Yes, okay, I think I understood. If we have the different configurations and a lot of flaky tests and a lot of beta, let's say, so we have less coverage, and still we need to put something in production while the tests are stable or beta or flaky, right? This is the...
Well, you have a run, like, well, maybe 3 runs, I don't know.
Can you please talk closer to the microphone?
You have 3 configuration, beta, flaky, and release, yeah? So you make a decision to release content based only on the release results, or based on three configurations?
Okay.
Are you basically you're asking if the release is based on what state? Something like that?
Something like that.
So the answer is release or version is based on the stable tests, only stable tests. and not flaky or beta or fail beta or something like that. We have run modes. What?
But it undermines quality assurance, I think. If you release content that is not covered 100% or something like, not as it was intended.
You're saying so if we don't check or we just connect the release configuration to stable tests, we have less coverage, and we might put something in production without any coverage. This is basically.
I was wondering what do you do if some, for example, flaky test failed? Are you 100% sure that they failed because flaky or because there is some bug hidden in those flaky tests, for example?
Okay, I understand. If we have a test which is starting to act flaky, and it's actually a real bug. This is okay. So this is why the algorithm must be super accurate, and it's very, very sensitive area. So usually, if we identify a failure or even a few failures, we don't move it to flaky. Only if it's something similar to what we've seen in the demo, like pass, fail, or pass, fail, some kind of pattern of flakiness. And it's something we always need to tweak and understand. And up until now, we didn't see.
Okay, thank you.
For example, if it will fail 4 times in a row, it won't be flaky. It should be fine.
Yes.
Hi. First of all, I want to say that it's a great idea, but it's make my test slower because it sends requests to the server or DB. So can I use it with my unit tests? It will be useful.
Use it with what? Excuse me?
With my unit tests.
Unit test, to be used in unit test.
That's a good question.
We like in tests which run much more often and very fast, faster than end-to-end test, of course. Okay, what do you say? I have an answer, maybe. I think you can use it. It depends on how you implement the server and if it's efficient enough. I think ours is okay. It should handle unit tests. It gets hundreds of requests every second, I guess. And I think it can be used. It's quite fast.
Actually, we found that ever since we're using this server, maybe it added 1 minute to the whole run of 100 of tests.
Yes, total of suite.
Yeah,
yes.
It's not something you can't live with.
Oh, you collect all results and send once, or you send every time results of test?
Each test send its result separately.
Okay, thanks.
But again, it depends on the implementation. You can just implement the client differently and put all the results on the side and then send. But yeah.
Hello. I
Hi.
have a question concerning to automation manager application. As far as I understand, it is your custom solution.
Yes.
That implements in your company, yeah? So it cannot be implemented in another project.
Yes.
Yes.
And the second question, does it support another testing frameworks, not only JavaScript, Java test framework, JUnit or TestNG?
Of course. Yeah, it's completely, it's quite independent. Yeah, because you can just send the test information and not related to which language wrote it. You just send requests to the server.
Yeah, the whole backend part is, it's on the side, and you just will need to implement some small, let's say, yes, some kind of driver for the run results, or some kind of watcher plugin or whatever, which just sends the results to the server. And it's in a REST API, so no problem. Yeah.
Okay. And what about experimented and versioned annotations?
This is interesting. Yeah, we didn't address those, but it's some kind of internal way of work that we do at Wix. We have the ability to open features before they are released to everyone, and it's being done with the experiments and the versions as well. We have different annotations on tests, which tells us this test should run only on a specific version. And this is just another filter in this manager for this kind of features that actually we can do a different lecture on each of those about how we work at Wix.
Is it as well? Is it custom annotations as well?
Yeah, those are custom.
Thank you very much.
Thank you. Okay, so this is it. Thank you very much. Good luck.